Hello, all right. This one's already going to be tricky enough to explain um, on video. So I'm going to try to enlarge this a little bit more. I'm going to do my best. So anyway, current. In physics, we say current leaves the positive terminal and returns to the negative terminal. All right, so we got a couple things going on. So this is going to look a little messy. I'm going to try. So these are north and south. These magnets are permanent magnets. So our field would be going north to south because it's outside the magnet. So I'm going to use my red lines for that. All right. So it's a uniform field. The wire goes through the uniform field, and using my right hand rule, my thumb is going to point in the direction of current, and my fingers are going to wrap around this direction. So obviously that's not going to help you, but it's going to wrap around this direction. Current's going to go around. And if we go to the other side, my thumb is now pointing this way with the right hand. And there's my fingers going that direction. So obviously, artistic skills are not the best here, but my arrowheads will be going that direction. Okay, so right hand rule. Number 3. Our fingertips are going to point in the direction of the red arrows. So with your right hand, you're going to point your fingertips, right fingertips at the south block, or the south magnet. Your thumb is going to point in the direction of current. So it's going to be following the green arrow. And when you do that, the resulting force, your palm, is facing down. So on this wire, there's your force, okay? And that's acting on this wire, so it should really be underneath. So let's see if I can slide it underneath. All right. So there, that force is pushing, or the magnetic force is in that direction. Similarly, when we go to the other side, now your fingertips, so your hand is going to flip open. It's going to be pointing up to the ceiling because your thumb has to follow on the wire there. So that means that the force arrow is going or pushing in that direction on that wire, the one that's returning. So that being said, now Newton's third law comes into play. So this is similar. This is similar to you being on ice and you're pushing against the boards. So you push against the boards, you're going to go in the opposite direction. So because the force is pushing in that direction, this particular axle, so this axle here, there's no friction, there's nothing holding it back. So that means it's going to want to rotate in the opposite direction that it's being pushed. So Newton's third law would push backwards. So it's going to rotate in the counterclockwise position, or direction, I should say. All right? So that's the reasoning for the counterclockwise rotation. Hopefully that makes a little bit more sense. My diagram or drawing's not the greatest, but hopefully between that and the voiceover, that gives you a better feel for why it works that way. If you have any other questions, let me know, and I'll see if I can help you out.